Right, so I think we probably are ready to start now. So my name is Ingvar and I'm an acoustic engineer at Treble. I've been working here for a few months, and part of what I'm doing is I'm one of the person answering your support about Treble. Today's webinar is going to be about simulate loudspeakers in Treble. So we're going to look at how to import and work with loudspeaker as a source in Treble. As you probably know, there's many loudspeaker data formats out there, but most of them are only used by manufacturers, and few of them are available for users. So Treble is using CLF, or Common Loudspeaker Format, for predicting loudspeaker inside the software. Many loudspeaker manufacturers, they have CLF formats for the speakers, and that can be downloaded from the website. Users can download and import their own CLF or CLF files that they have downloaded from the manufacturers by themselves that are not already in our database. For this webinar, I made a hall that is just an imaginary hall. That is, we can call a conference hall or something like this. So I just put in a loudspeaker that could be like a common loudspeaker or a typical loudspeaker for that kind of a room or purpose. We will go into that later, but just to keep in mind that this is like not a real hall. It's just like something I made for this webinar. For this demonstration purpose, I made a two version of the hall. I made something that I call soft hall and something that I call hard hall. In other words, is let's say less reverberant or more reverberant. So we will see. We were just looking at the different parameters and see how that comes will add up with the loudspeakers, and we will also use the oralizer to listen to the outcome. So I'm not going to go in depth into how to set up, or actually not going to talk at all about it, how to set up the model in SketchUp, but this is the hall I draw in SketchUp, and you probably already know how to use the Treble plugin from SketchUp to get into Treble. So we just jump straight into here and open up the hall. And this is the hall, and we open up the simulation. When we are arriving, when the model arrived in Treble, we will first, what we will do is to assign material to each surface. As you can see, we have a lot of surface for every wall and things inside the model. So like a stage wall, stage, side walls, and so on. And for this case, I used materials from our database. And as you may know, there's a lot of materials already inside the database. And we can choose them, use them as we will. We can have more information about the materials by clicking the icon down here, and we will have the absorption coefficient. And we can also make our own materials if we like, just by clicking new material and then punch in the numbers from the datasheet, the absorption coefficient numbers from the datasheet. That's have been covered in another webinar, so I'm not going to go through that now. I'm only going to show you how it looks, so you know where it is next time you need it. We also have the scattering coefficient for each surface. And since this is the hard or the more reverberant room I opened, most of the surfaces, they are flat and reflected. The only thing that we can say that's maybe not as flat as and reflected is the seating you can see here. I just draw a seat like a bench or something like that. and that's probably accurate enough for this purpose. To set up the simulation, I think I'm not forgetting anything, and maybe you just have to send me a chat if I'm going too fast or skipping something. Yeah, so the next thing is basically to set in sources and receivers. So that's basically where we are adding or getting to with this webinar. We add in source by clicking the plus icon, and I will just do edit and we'll go it out again. Let me see, and here it is. And by default, it comes up like OmniSource. If you click on that, we will have a list of available sources. In our case, we are going for the amplified sources. So we have a list of loudspeakers that have CLF format behind them. So they are already in the tool. Like I said, there's no problem to go to a manufacturer's website and get this information, download them and import it into Treble. The thing you do then is just click new. You will go to source definition and you will have to fill out this form, of course. So you can categorize your speaker. Then you just click browse. And if everything goes well, we will find something like this. This is just a random speaker from Martin Audio that I used for this demonstration. And to import the speaker, I would just simply click the speaker in interest, open, and add it into my directory. What I forgot here is I could share it with the organization if more than one people are working together, like more than one users in the same company. Then we will get the information about the speaker. We will get the directivity pattern in let me see, I have to move here a window in top and side view. And we will also have the on-axis SPL, what will describe the SPL and the frequency characteristic. I think I will just go out from that for now. What we could also do is, let me know, I'm going to choose something like this. CDD, was it? Just like that one. And yeah, when we have assigned the speaker, we can go and get more details about it. We can either do it here by clicking here. We'll see the same information as when we were importing it in the tool. Here we can share with the organization. And we can also click on this icon, and there we have more detailed information, and we can have some equalization. So we could do some EQing and octave bands and adjust the level of the speaker. And just to demonstrate that, we have something here like let's say we would take 500 hertz down 3 dB, just for example, to see something, and then we'll see we will have we are changing the frequency response of that given speaker. We can also change the level if we are level adjusting sound system, let's say -3 dB, and we will see that we are changing the level of this speaker. We could also go here and choose another speaker for whatever reason we would like to, but I'm not going to do it at this time. To locate a speaker inside our model, we could either, the speaker is placed here, just for you to know if you don't see it. We will then can use the X, Y, and Z axis to locate it, or we could click on the icon, grab in this handle, and drag it so we can maybe like put it approximately where we want to be. So if it was like a small under balcony speaker who could be placed here, this black arrow is showing in which direction the speaker is aiming. So now we aim it into the auditorium, and it's just aimed straight forward. We can aim it up or down as needed. I'm just punching here the numbers instead I can get, of course, just set in exact numbers, something like this. But yeah. And we could rotate it as well. Now, here we have the information about the speaker. Like I said, we have a quite good collection of speakers in our database. But like I said, there's also a lot of data available at the manufacturers. Receivers. Let me see, maybe it's a question here. No question so far. Yes, we have a question about the GLL files or for line arrays. At the moment, no. GLL is owned by AFMG or the E Suite, so this is something more complicated. This will it be possible to place speaker more close to the wall or maybe even inside the wall? I think for now we are limited. It's actually half a meter away from the wall, but yes, this is something that we are working on and will be released hopefully soon. So we are working on that among other things. Okay, so just let me go on then. Then we will put up a source, so we will have a receiver, so we will have any idea what's going on inside the model. So as you probably know, we are here. I'm setting in point sources that kind of act like microphones, and in this case, I put in 6 point sources, 1 on stage, 3 in the actually in the middle of the auditorium, 1 up on the balcony, and 1 here under the balcony in the corner. We also have a possibility of setting in a surface receiver. And in this case, I have 2 surface receiver, 1 on the auditorium and 1 at the balcony. So these surface receivers, they can give us like a heat maps or information of like a broad how sound is distributing over the hall. And this can be really handy, especially when we start looking at some problem areas, like under balconies or something like this. The receivers are set in kind of in the same way as the sources. We have X, Y, and Z axis, and we located them where needed. On top of that, of course, the surface receiver, they also have length and width. So it's the middle point, what is this X, Y, and Z axis, and then we can rotate them or angle them as needed so they will fit the area that we are aiming at. So like in this balcony, we can see it's in the same height from all the seats, should be in 1.2 meters for sitting audience, and just laying all over the balcony area. We can turn them on and off, just the visibility, if they are blocking the sight of something or some other things that we are doing. Same goes for the point receiver. No, it was not. Sorry, it was me. Yeah. So I know I'm get to going over this maybe a little bit fast, but I guess that most of you that attend have already done some simulation. So, and maybe you already used this feature before, so you probably have to stop me or ask questions if I'm going too fast. Then going to settings for the simulation, we have something that I call survey. That is like a quick estimation of the parameters. It takes shorter time than running the whole simulation with the web-based and GA solver. Then we have we mainly use it when we are like setting up simulation and we're trying to get our ballpark or something like that. We have something called default, where Treble success the transmission frequency between the wave-based solver and the geometrical solver. And then we have the advanced settings, where you can set the transition frequency between the wave-based and the geometrical solver yourself. You can always also choose between impulse response or the energy decay threshold dB for the basically the length of the simulation, to be sure that you are calculating every band for all frequency. So here we can also choose between the wave solver only, geometric oscillator solver only, or both solvers. We can also set the number of rays. Default is 10,000. I usually put it more up myself, maybe up to 50,000 or something like that. And then the image source order. So this is everything we can play with. And Treble will estimate how long the simulation will take. Of course, the bigger model, the more sources and more receiver, it will take longer time. As long if you are increasing the transition frequency, I will also expand the time of your simulation. Let me see, and I will just hit here to revert to the simulation or the setup that we were entering originally. Due to this simulation time, I will not run the simulation at this point. I will rather go into the results. I'm just going to look if there are some questions here. No questions. No questions so far. You just, if you have any questions, please write them in the Q&A, and I will. Oh, well, there is one. Is Treble looking to implement a feature in the oralization cellars that allows one to add plugins in the mixer consoles? Let's say you're working with loudspeaker sources in the oralization and you want to control the speaker source like Audio Engineer by adding gate, equalizer, compression, reverb, and other plugins. In many real-life situations, you want to be able to control loudspeaker more than just equalizing them, such as front of house positions, something similar. I know this might be a bit far. No, this is not on our drawing board, and but I have had question about if we can use impulses or impulse response from Treble to convolute reverbs, and I'm not sure if anybody have tried that, but I cannot see any anything that is against that. And yes, yeah, another question: any instruction to save calculation time and get still more or less realistic results? I think the transition frequency or the how far up you go in frequency with the wave-based solver is probably the most time-depending thing. So I would guess that the answer is that it's probably how many sources you have and how big is the room, how high in frequency do you need to go with the wave solver if you are just trying to save time. Going into the results, like I told you before, I have two cases of the same room. We have here maybe we'll start to go through the parameters first. We have here the time-consuming parameters, then we have a clarity parameters, SPL, and this open office parameter that is probably not relevant for now. We can look at all simulations from looking from like a source to receiver combination, whatever we like in that matter. So, and for all the parameters, I think if you are simulating loudspeakers, probably the main thing you want to look at is, of course, the SPL and then the STI, especially if you are working with conference room or somewhere you're gonna be amplifying speeds, then I will say that the STI is probably the most important parameter, along from the sound level. And we can also average the receivers, either all of them together or in whatever compensation we like this. Or we can switch here between seeing a geometrical or ray-based or ray tracing bit of the simulation, the wave-based or the hybrid mode, where the hybrid mode is showing, if you go here, we're showing the transition frequency. Below this here is the wave-based solution, and above this is the ray trace or geometrical solution. We can download either the spreadsheet with the parameters that we are calculating up here, or we can download the IRs to use them for somewhere else. This is the wave files that will be generated. And let me see, it's a zip file that comes like this, just for those who haven't seen that already. Yeah. And this is something like that. And just keep in mind that this second order ambisonic files here, these are actually 9 wave files, and you have to open it in something like Audacity or Reaper or something like that to get the whole files. If you go back to here and we just look at this from the right side, and we add in the soft version or the less reverberant version of this whole, and we do the same. We combine all the receiver, and then we will see the huge difference in T20 between these two settings. Of course, I made them so they will be a huge difference. And we will also see the huge difference in the STI, sorry. So it's probably that one we are gonna look the most at. This is probably all familiar with most of you already. But the surface receiver might be, I'm going to focus a little bit more on that now. I'm just going to take that out for now. And here, of course, we have the same parameters we can look at as in the parameter view here. Yeah, sorry, I forgot the plot. You knew I was getting something. Here we can, of course, see the impulse response. Let me see. I'll do it like this. Then we see the impulse response and the frequency response. And we can compare them as well as others like this. And we can zoom in, and we could be able to see room modes or eigenfrequencies even in the frequency response. But this is a big hole, so it's probably really low in frequency. And if I just to show for comparison, I can go here and go to other receivers, and yeah, or change the something like this. Yeah, so going to the surface receiver, if we're looking, yeah, it doesn't matter even if we're looking from the right or left side, it should be the same. But of course, we have the same parameters here that are calculated and displayed. Maybe there's some question here. Yeah, I have noticed that the oralization is sounding much better than the convoluting IR locally with an anechoic file. Sorry. Is there oralization simply taking the mono IR and applying it to HRTF, head-related transfer function, or is it, or is there anything else? Yeah, yes, it is. It is. Which frequency can be displayed from the surface receiver? Let me see. We're just going into that. So if we look at the T20 for start, we can here go and look at just on the drop-down list. We can look in octave bands from 63 Hertz to 8 kilohertz. If we look at the SPL, that's maybe more, in this case, more what we are focusing on. This is same goes for that. We can in octave bands look for from 63 to 8 kilohertz. From my experience, something between 1K and 4K is really usually really good approximation to aim a speaker. So if you look at 4K, then we can see that from this specific loudspeaker placement, we are covering quite well the nearest to the speaker, of course, and then some of the balconies are okay. But as we can see under here, that the under the balcony, especially here under these, we have this wing on the balcony, we have almost area with no sound. So this is actually one of the advantages of using Treble for the simulation, is that most of the manufacturer speaker software, they only predicting the direct source, so boundaries are not real in the simulation. So you will not see these shadow, or at least it will be much harder to see it than using Treble. What we could do also is if we click the mouse somewhere here and we hold the control key, and then we can get like a multiple or get the results for the surface receiver, and we can see how sound distribute throughout the audience area or any surface of interest. So this can also be really valuable to see how that sound distribution is going. I can, for demonstration, go to the balcony speaker, and then we will see how, when we're still looking at the 4K, how the balcony speaker will act on the balcony and how it will have really little effect on the main auditorium. We will see maybe there's a slight some sound coming down here, but of course if you go down or lower the frequency, we will see more effect of it because the speaker will get more omnidirectional with lower frequency. It's a relatively small speaker. It's a 15-inch and a horn. So it's and it's really not a big cabinet, so the cabinet has not that much effect on the directivity in maybe, I don't know, a frequency under 200 or 150 hertz. There are some questions. I'm just gonna go. What is the maximum number of sources allowed? I had trouble in the past organization a 15 speaker system, big home theater. Johannes, what's 20? No. Okay, can you take this? Read it. Okay. Johannes will answer it in the comments. Is it planned to extend the frequency band below 63 hertz in the future? Yes, this has been discussed, and yeah, it has been discussed. So I will say in the future, yes, but when, not sure. Is there any plan for other oralized format on binaural, stereo, ambisonic? Well, we have the second order ambisonic, and then of course the mono. That is just like the point source, and then we have the second order ambisonic. So apart from that, at the moment, no. I think we will let the second order ambisonic do for now. Will it be possible to simulate multiple sources at the same time? Yes, we are working hard on this now, and that will hopefully be available in not too long time. And there will be probably some other, or not, there will be some other updates that will come along with that, but hopefully really soon. It would be nice to be able to set a fixed range for the SPLA color for better comparison between different frequencies. You're absolutely right. This is the one of the things that we have is on our list and will be implemented hopefully before it's hopefully soon. So yes, as you probably noticed, then the scale changed. So we have those that can be a little difficult to compare things when the scale is changing. So just let me see if I just punch in something to freeze the scale like this, and then we can but this is obviously too loud, so we have to let's say it's like something like this, or even more like So if we do something like this, and then we go to the balcony again, it's really low. So that could be also due to if we go here, we exit this, and I go here, I can see. I think I remember I was playing around with it. Yes, it's in minus 10 dB, so it's taking down 10 dB. Maybe not a smart move, but or maybe I was just trying or playing around in the software and forgot to increase it again. That might also be. We were here. Yes, so we can also look at the STI. What is happening now? No, sorry, STI was on the wrong button. And here we can probably also then compare between the two cases. We are looking at the same speaker. We are looking at the same receivers. And we can switch between these two and see how the STI is improved by better acoustic. If I just put something down here. Yeah. Would it be possible to simulate from speaker to receiver on another speaker? where's the email from? Yeah, I'm not quite sure actually what you mean there. We can, like, if we are in the receiver mode here, like at the point receivers, we can, I'm just going to close this. We can choose whatever source we have and whatever receiver and juggle that or see the compensation between that as we like. What we can also do, and what I often do, is like open the same simulation again, and then I can see difference between either sources, different source positions, or different receiver positions to see how certain parameters are varying over the venue or room of interest. I hope that answers your question. Going to the oralizer, we can choose there. Of course, we get just like a listen to the room as it is, or we can do some comparison between different setups of the room, like this, or we can choose between several conversation of the room, and we can then jump between the receivers. To do that, we will have to add in some source, and in Treble we have a library of all kinds of source, claps, instrument, some like office noises or coffee house noises, music, noise signal, people talking or speech, or some soundscapes. So it's quite a good collection of test sounds we have. They are recorded in anechoic chambers, so they should be without any reverberation or room characteristic. You can also load your own wave files. For instance, maybe not here. I think I have it somewhere here, just to demonstrate. There was just a Steely Dan song I split up in left, right, and mono, so I can use that. That was for another demonstration. I was doing similar things, so you could then have the left side in the left speaker and the right side in the right speaker, like a not somehow combined stereo signal in both of them to get more realistic oralization. You can also save parameters or setups, or a load a setup. I'm just gonna throw this away now here, and I'm gonna load a setup that I made for this demonstration. Let me see a second. This one here, which I have a male voice, so that could be somebody just reading up in the on the stage. And I have these two cases again that we have been looking at, the hard case and the soft case, or the less reverberant and the more reverberant. Let me see how to move this. And we have these three sources that left, right, and balcony feed up, and we have these point sources that we had before. There is possible also to share the oralization with a customer or people in your organization. You just simply put in the email, create the link, and send it. And you can have the expired date, and yeah, do some notes and stuff in this. So let's see if this works. Okay, I'll have some questions. I'm gonna take them first. Many audio tests use RT60, which is the diagrams. It's RT60, or can it be covered to? So RT30 is basically just what's the word I'm looking for? It's the same. It's just over 30 decibels instead of 60 decibels, but it's RT60. You can multiply RT60 from it. When you upload a local sound file into Oralizer, I've noticed that you're not able to share that oralization currently. Treble only allows you sharing oralization with the sounds that are in a Treble library. That's true. That's one of the things also we're working on. Are you considering on allowing this, or could there be a copyright implementation? The reason for it? No, I'm not actually. I know this is something that we have been talking about and we want to fix. I'm not sure how if it's copyright or not, but it has something to do with the program itself, how the system is built up. So I'm not quite sure actually. Well, I have not simple question for that. That's more deeper under the hood than I can answer. But yes, this has been discussed, and there is some work going on how to solve this. But when it's gonna be solved, I'm not sure. But this is like this noticed, yeah. And thank you. It's a good question. Okay, so I'm gonna try to run the oralization and see if that works.
In a world often characterized by its fast pace
So
and
just by
self-centered
clicking
pursuits,
the
there's a beautiful and heartwarming
I
aspect
have to
of
lower it
human
down
nature
here,
that
so it will
stands
not
out.
be too loud in
The
your
kindness of strangers.
streaming.
Picture
Like this, okay?
You're rushing through
I
a
got the
crowded
thumbs
subway
up,
station,
so it must be okay.
battling your own anxieties and
So
stress,
when
and
you just
suddenly,
press the
a stranger
play
notices your
without
struggle
the play button
and
here,
offers you their
without
seat. It's a simple
choosing any
act, but it
receiver,
can make your
you're
entire
basically
day
just
brighter.
hearing the dry
Or
recording.
consider the times when you've lost your way in an unfamiliar city, feeling lost and disoriented.
The minute I
a passerby
punch
stops,
some
offers directions,
receiver, you will
and
get
even walks with you
that
to ensure you
point.
find your
So I will push
destination.
this one that's here
This
in the
gesture
middle of the
kindness
auditorium.
can restore your faith in humanity. The kindness of strangers transcends geographical boundaries. Think about the countless stories of individuals
and we can hear that. At least I can hear it in my headphones. That when I'm turning my head, that the second or the ambisonic is working, because the sound is moving around
Even in the digital
as
age,
I move my
the
head.
kindness of strangers can be felt. Online communities and social
I
media
can change here
platforms have
to a
become
different
places
settings of the
where
room,
people offer support, share their
and we can
experiences,
instantly
and
hear
help each other
how the
navigate life's
better
challenges.
acoustic, at least
Often with
better
nothing to
acoustic
gain
for
but the
speech,
satisfaction of helping
is
others.
making everything more
These acts of kindness from
clear.
strangers remind us that deep down there's a wellspring
If
of
we go
compassion
on to the
within humanity.
stage,
They
and
demonstrate
now
that
is
even
what
in
we
our
will
most hectic
be
moments,
hearing or
a single
experience
act
if
of
we were
kindness
standing
has
up
the
on
power
stage
to
as
stretch
the
across,
speaker and
bridge
looking
divides,
into the
and make
auditorium.
the world a better place. So let's remember to appreciate and reciprocate
And we
these
can
acts
also
of
again
kindness.
change the room.
They are a statement to the innate goodness that connects us all. The kindness of strangers is a reminder
Going up on
that
the
in this
balcony,
complex world, we are, at our
we are
core,
hopefully, even though
bound
it's
by
probably
empathy
lower than it
and
should be,
compassion.
we could be hearing the
In a world
effect of
often
having the
characterized by
balcony
its
speaker
fast-paced and self-centered
up there.
pursuits,
So
there's a
I
beautiful
will,
and
let me
heartwarming
see.
aspect of human nature that stands out.
Okay, I
The
cannot
kindness of
reach it. Okay, it's
strangers.
because the
Picture
zoom is
this.
kind of over
You're
my
rushing through a
screen.
crowded subway station, battling your own anxieties and stress, when suddenly a stranger notices your struggle and offers you their seat.
So bear with me for a
It
second.
can make your entire day brighter. Or consider the times when you've lost your way in an unfamiliar city, feeling lost and disoriented.
So
Out of nowhere, a passerby stops, offers directions, and even walks with you to ensure you find
we
your
can hear that.
destination. This gesture of kindness can restore your faith in humanity. The kindness of strangers transcends geographical boundaries. Think about the countless
It's probably
stories
even
of
more
individuals
audible
helping each other
when we
during
have
natural
the room
disasters.
soft.
Whether it's neighbors lending a hand to rescue flood victims, or volunteers traveling across the country to provide aid in times of
So we had
crisis.
to make it up for the 10 dB
Even
I
in
took
the
down.
digital age, the kindness of strangers can be felt. Online communities
What
and
we
social
could
media
also do
platforms have
is we
become
can
places where people
go
offer
to the
support, share their
receiver that we have
experiences, and
under the
help each other
balcony.
navigate life's challenges.
And of
Often we're
course,
looking to
the
gain the satisfaction of
balcony
helping
speaker
others.
does not do anything there. But if we
These acts of kindness
mute
from
the speaker
strangers remind
2
us that
here,
deep
that's one we
down,
see,
there's a wellspring
then
of
it's only
compassion
speaker,
within
no, sorry, yeah,
humanity.
only speaker 1
They
that's up
demonstrate
here,
that even in our most hectic
in the
moments,
shadow of
a
the
single act of
this
kindness
view.
has the power to touch hearts, bridge divides, and make the world a better place. So let's remember to appreciate and reciprocate these acts
And
of
if we
kindness.
have the
They are a
worse
statement
acoustic
of the
or
innate
more
goodness
reverberant
that
at least,
connects us all. The kindness of strangers is a reminder that in this
it's
enormous
really hard
world,
to
we are,
understand
at our core, bound by empathy
what's to
and
be
compassion.
said.
In a world often characterized by its fast pace and self-centered pursuits, there's a beautiful and heartwarming aspect of human nature that stands out: the kindness of strangers. Picture this. You're rushing through a crowded subway station, battling your
Oh,
own
okay.
anxieties and stress, when
So I think
suddenly
my
a stranger notices your
laptop
struggle
is
and offers
struggling
relief.
with all this information
It's
I
a
have to
simple
be
act, but it can make
doing.
your entire day brighter. Or consider the times when
So
you've lost your way in an unfamiliar city, feeling
yeah,
lost and
I think my
disoriented.
laptop is
Out of
had
nowhere,
it.
a passerby
It's too much
stops,
for it.
offers directions, and even walks with you
Okay,
to
so
ensure you
which
find your
one is
destination.
open?
This gesture of kindness is
Okay,
to restore your faith in you.
right. So we have some more questions. Yeah, I think this cracking sound that we're hearing is probably due to that my laptop is just running too much thing at a time, and it's also Zoom could be have some effect on that. It should be without any cracks or noise, but yeah, I think my laptop is really struggling here, so you can probably not hear the fan, and it's overheating, I think, doing the whole thing. Is it possible to change phase of the source? No, it's not possible to change phase of the source. One thing that will come when we do the source summing is that we will be able to change source. We probably also put in a delay for the source. You could probably hear that when we went up on the balcony, that you have a time difference between the mains and the delay speaker for the balcony. So that's also one thing that's going to be added in. So we're going to have more parameters to choose and change for when we will release the source summing. Yes. Right. So I think that was basically it in a nutshell. Was I was going to demonstrate. It sounded to me like I was rushing quite a bit through it, but still it was 50 minutes, and I think they said to me I have to be under an hour, but we have some time for some questions, so please, if you have any more questions. No, no more questions for now. Well, there is one. Are there any plans to implement surface receiver statistics anytime soon? Johannes, what do you say about this? No, we don't know. No, it's probably, yeah. I mean, at least we will notice this, and this will go into our future request log for sure. Yes. Will there be a way to import an existing RT60 test to compare optimization with the current state of building? Yes, it will be. This is one of the things that we are working on. Exactly when this will be released, not sure. But yes, this is definitely something that will come. It would be very useful for us if we could insert the measured room acoustic values into Treble and then simulate the optimization in Treble. Will this be possible? Yes, this will be possible. Yes. Like I said, this is one of the future things that we are working hard on these days. When it will be released, not quite sure. We are looking at a lot of possibilities, what data to import and how to import them. But all of this is really valuable, and we will for sure, this will come, hopefully sooner than later. Right. Thank you. So, well, I think then we have reached the end of this webinar. I just want to thank you all, really thank you for this, for attending the webinar. It was really fun for me doing this, and I hope we can do some more great stuff that will come beneficial in your work. And I just also want to remind you of using the support chat. If you have any questions, we are always there. And it's really valuable for us to hear your user experience and get your comments about what we can do better, and also if we are doing something good, what we are doing good, so we can keep on improving Treble to your use and need. Right, so I think that will be it for today. Hope to see you again. Thank you very much.